Hey everyone, Mike here with another GIS tutorial. Today we're going to attempt to create some city boundary polygons from a couple different data sets. And the reason why I'm doing this project is because I recently came across a customer request where the customer was requesting some data to include all U.S. state boundary polygons and all U.S. town polygons. Now, it was easy to find the U.S. state boundary polygons, but in my search to find U.S. town polygons, I had an easy time finding point information. But when it came to city boundary polygons, I generally only found polygons for like the top 500 U.S. Cities, for instance. Nothing not near as comprehensive as polygons for all of the towns in the United States. So I decided to see if I could create that myself. So before I jump into ArcGIS Pro, I'm going to go over a outline of what we're going to do. We're going to be working with two different data sets. One data set is the 2022 Tiger Line census, U.S. Census data, the zip code tabulation areas. So polygons based on zip codes in the United States. And the second data set is a data set I found from this Simple Maps website of the U.S. States Cities database, and is actually a non-spatially enabled data set that came in the form of a CSV file. In ArcGIS Pro, I brought that CSV file into a table and then made points based on lat longs, which is what you'll see on the screen. It is not, it's just tabular information. So our goal will be able to create city boundary polygons by combining the two data sets, because our zip code information, zip code polygons don't have all the information we need to accomplish the task that we want to do. So I've done some investigation in the data sets, and I found that the U.S. states cities data set has zip codes nested in this zip columns. Zip codes nested in the zips column. And then I found in the 2022 Tiger Line dataset that there are zip codes found in the GeoID 20 column. So we'll need to find a way to combine those two datasets. So the steps to do that, we're going to create a Pandas data frame for the non-spatial information. Then we'll unnest the zips column so that we have one zip code per city. So essentially we'll have one row per city name. Then we'll create a geospatially enabled Pandas data frame for the polygon information. And we'll merge those two data sets using our joining criteria, which is the zips column and the GeoID 20 column. We'll do a little bit of data cleaning. We'll export that result to a new shapefile. And when we export it to a new shapefile, we're going to have the same polygons based on zip codes. Only at that point, we'll have a column with the city names. So we'll have to carry out one additional step to make new polygons based on the city. And we'll do that by using the dissolve geoprocessing option in ArcGIS Pro. And we'll dissolve based on the city column to create the city boundaries. So let's kind of take a look at what I have already, and then we'll jump into the Jupyter Notebooks. Okay, so what I have right here is the point information that I converted from the non-spatial data, and I have our zip codes, our census data zip codes. So I'm going to go ahead and open this census table, and I will open the city table as well. Now, in this cities table, let's use this select by attributes and kind of do some investigation here. I want to see the city of New York. So I'll go ahead and click apply, hit OK. Here in the table, I'll click this show selected records icon to simplify our table a bit. And then I'll click this zoom to icon to zoom to New York. And not quite zoomed in enough, so let me zoom in some more. Now, we know that New York is bigger than this one point. And New York's a lot of this area where I'm moving the cursor. If I scroll over in the table, you'll see there's the zips column that has all of these zip codes that belong to New York nested in that column. Now, it's very difficult to do, or I'm not sure it is possible to do with some of the traditional methods in ArcGIS Pro. So I'm going to use the method with Jupyter Notebooks and Pandas to be able to join these zip codes to our other data set. And I'll go ahead and just show in our zip code polygons this GeoID column that has all the zip codes. So let me clear the selection on that point and turn this data off. It was just for visual purposes. Let me zoom back out to the United States. And we're going to be in Jupyter Notebooks for a bit. And at the end, we'll be back here in the map to see what we made. Okay, so let's jump over to the Jupyter Notebooks. Let me close these tables. And I already have the code written. I'm just going to walk through, run the code and walk through what I have written. In most of these different code blocks, I've included a link where I found some helpful information for generating the code. So the first thing we'll need to do is import pandas as PD. And then we'll also need to import GeoAccessor and GeoSeries Accessor from ArcGIS features. The GeoAccessor and GeoSeries Accessor allow us to work with the shapefile polygons within a geospatially enabled Pandas data frame. So let's go ahead and run that. I'm going to hit Shift plus Enter to run the code. It's a hotkey that you can use within Jupyter Notebooks. Alternatively, you could also hit Run every time. So the module is imported in successfully. So the next thing I'm going to do is prepare the table from the non-spatial data. So to do that, I'll use the Pandas read CSV function. So I'll define a variable called dataframe underscore CSV and use the read CSV function and fill in the file location. And then I'll run that. And I'll also use the .head function to view the first 5 rows in this data set. And as we've already kind of done in our prior investigation, we'll see in the zip columns all these nested values. Now, we'll need to make sure that those are no longer nested to accomplish our goal. So the first thing I'm going to do is simplify the table. So I'll go ahead and make a new dataframe underscore new. I'll reference our dataframe underscore CSV and index the city and zips columns. And I'll run that. And we'll see that now we have a table that just has the city information and the zips information. So now we need to prepare the zips column so that we can make one row per zip code. And to do that, we'll use this string.split function to make a list in this column. So I'll go ahead and run this, and then we'll compare how the tables look. And you'll see the new table has a bracket, and it has commas in between each value. So it's now a list in here. It's, previously, these values were written in here as just a string of values with a space in between each value. And the string.split function allowed us to make a list and use a space as a delimiter to make that new list. And now that those values are a list, we can use the pandas.explode function to separate those out one by one. And it's important here to go ahead and write dataframe underscore new to redefine the variable on the left side of the equal signs before you run the dataframe underscore new dot explode. If you don't do this step, you'll see a result, but it won't actually save. So let's go ahead and run that. And now you'll see our table has one zip code per row, which is what we were looking for. And you can see these values correlate to the values in our list. And I can go ahead and let's look at the values at the 500th row to the 510th row in our data set. And you'll see Chicago, for instance. These values are the first values in the Chicago's data set. So we've gotten where we want to go with the non-spatial data. So the next step will be to do a similar process, but with our spatial data. So to do that, we'll have to create a new data frame, and we'll name it geo_df. And the syntax will be this pd.dataframe.spatial.from_feature class. And inside the parentheses, we'll reference where our data is located, and we'll go ahead and run that. This is going to take a few minutes, so I will cut forward to after it's done running. All right, so about 5 real-world minutes have passed, and our geodata frame has successfully been created. And we ran the .head function, so we can kind of see that table, and it all looks good. So our next step will be to merge our spatial and non-spatial data together. And to do so, we'll use the pandas.merge function. And we will make a new data frame variable, call it dataframe_merge. And then we'll use pandas.merge. And in the parentheses here, we'll reference our geodata frame and reference our regular data frame variables. And for this left on parameter, we will reference the geo ID column from our geodata frame. And then for this right on parameter, we'll reference the zips column from our regular data frame. So the left on correlates to this left input variable, and the right on correlates to this right input variable. And then we'll use one final parameter, how, and we'll have that equal to right, which means when the data sets are joined, our new joined information will appear on the right side of the table. So let's run that. And now you'll see we'll have the same table that we had before from the geospatial data frame, except now we have the city and zips columns included. Now, moving forward, we're really only interested in keeping this city column. So we need to do some data cleaning. First thing we'll do is we'll drop the zips column, and we'll do that by redefining our data frame underscore merge variable. We'll reference that same data frame and use the .drop function. We'll tell it to drop the zips column, and we'll use this axis equals 1 variable or parameter to let Pandas know what we're referencing. I'll go ahead and run that. And then you'll see we have the same table, just without the zips. And the next thing it would behoove us to do is to check for null values to see if everything joined or didn't join. And we'll do that by using the .info function. So when I run this, it'll tell me that there are a total of 47,813 entries in the table. And then it'll list all of our columns and how many values rather, are in each of those columns in our data set. You'll notice the city column has all 47,000 values, but the rest of our columns only have 42,000 values. That means that roughly about 4,000 of our values didn't actually join up to one another. So a decision has to be made in our project. Do we want to go ahead and try to identify and fix these values before moving forward, or do we want to move forward and fix those values later? I'm going to make the decision to fix those values later. But I'm going to run a quick calculation first. I'm going to find what percentage of values that we were able to join. We were able to join 88% of our values. So I'm going to call that a success for now. We're going to have 88% of the cities in our data set are going to be part of this result. So yeah, I'm going to call that good for now. So to be able to drop those null values, we'll use the drop NA function. So let me go ahead and run that. And I'll run the info function again. And what you'll see here, is previously we had 47,000 total entries. Now we only have 42,000, and all the totals match. So that allows us, at this point, we are ready to export our result into a new polygon shapefile. And to do that, we'll use the spatial.toFeature class function, and we'll define a location where we want that shapefile to end up. So I'll go ahead and run that. This is going to take even longer than importing the shapefile into a geodata frame. So I'll go ahead and pause the video and cut forward to after it's done running. Okay, so another few minutes into the future, and our new shapefile has been created. And you'll see it's over here in the contents window. Let's go ahead and jump over to our map. And for whatever reason, this lock icon kind of gets stuck. I found that if I just right click and remove that layer and go back and find this data set and bring it back in, it'll show. So you might have to do that as well. Now we have our new data set, and this is going to look exactly like the zip code polygons that we had before. Only this time, if I select one of these polygons, right click on that layer and open the attribute table, we now have a city column. So let me go ahead and clear this selection and go back to our full table. You'll see that now we have all of these zip codes have a city associated with them. So we have one more step, and that's going to be to make a polygon based on this city column, so that all of the values, all of the zip codes that share the common factor of New York will have a boundary surrounding them that will designate the city boundary. So let me jump back to the Jupyter Notebook, close this table, and scroll down to where we left off. And to accomplish what we need to do, we'll use the ArcGIS Dissolve geoprocessing tool. And I've already got the parameters filled out. Really important is the dissolve field is based on city, as I just pointed out. So I'm going to go ahead and run that. All right, so that did take a little bit of time, but our dissolve function has finished running, and we now have a US city boundaries polygon. So let's jump over to the map and try to visualize what we've got. Let me go ahead and change some symbology here. Let me double click this, open up the symbology pane here, and let's make this a no fill, just an outline polygon. And let's make this a little thick. Oh, I don't know if I'm in the way. I don't know if I can hit apply. And then let's go ahead and turn on our zip code polygons, and with that one selected, there we go. With the zip code polygon selected, I'll go here to feature layer. Let's apply some transparency to it, and let's change the color. I'll right click on the polygon here, and let's change the color to something a little easier to see. And it's hard to tell right now, but let me zoom in to see the DFW area, Dallas-Fort Worth area of Texas. And you'll see we have our city boundary polygons, and we have our original data set representing a bunch of different polygons based on zip codes. I'll turn this layer off and select this polygon. And then I open this attribute table, go to my show selected records, and we'll see we have a polygon that represents Dallas. So we've effectively combined these two different data sets to make city boundaries across all of the United States. And so that's the project. I hope you had a good time seeing it happen. And let me know what you think. If you have any other tips in the comments, or give the video a like and share with your friends. Thanks.